Now, my goal with this is to create a wood framing, rough framing model that enables me to cut all the pieces of lumber that I need in my house in a factory where I can be much more precise and much control waste in a much better way. And then say code it all and take it out to the label all the pieces and take them out to the job site and put them together and have a perfect house that all fits together. Or in our case, a perfect model of a stud construction where everything fits together properly. So this is, to me, the key to efficiency, improving efficiency in the construction industry is doing more and more of the work in a factory where we can do it precisely and perfectly, and then assembling it on site where everything snaps together, sort of like a great big IKEA house. But a way, now Revit and BIM tools support this through the notion of the digital twin. So the digital twin is, the model of everything, the digital model of everything that exists or is going to exist in the real world. So every stud, every concrete, every brick, every mortar, every conduit, every duct, everything gets modeled in the BIM, so that we can essentially build the structure in the BIM first and locate all the possible problems and then build it on the site. Now that's an ideal. We're nowhere near achieving that, but in your career, that's going to be the norm. So that's why we're studying it now, to get you ready for your career. Now, a key part of doing that in Revit is if I go to this view, is basically counting everything. And if I go to this view menu, I can pick schedules, and I can create a schedule of quantities. And I get a dialog box here that lets me pick what I'm going to schedule, and I could pick generic models since that's what I've been using for this. I don't know, we could call it rough framing members. And then I've got all these fields or parameters of those objects, fields to put in my schedule. Important one is the type. I can put type in my schedule, and I could put volume in my schedule. And there's family and type, there's location, there's cost, all sorts of things that I could put in the schedule. I'm just going to go with these two. And it generates, there's the lumber test, the volume of that. And the 2x8s are all listed. The 1/2-inch plywood is listed. And I'm starting to get a list of all my elements in my model. Now, I'll go into more detail on doing schedules later. Go into more detail of doing schedules so that we can get the actual length of everything instead of the volume. And so we'll know how to cut all of our pieces. But I want to introduce this idea of schedules and getting a list of and tables of everything that we design and all the parameters associated with them, with each object, and getting this sort of tabular description of a building. Now, one more thing I want to show you is that over here in the project browser, and I'm just going to pull it out here so we can make it real big. You'll see that we've got different areas here. We've got the views, the floor plans, the ceilings, the 3D views, the elevations, the sections. We've got legends. I'm not going to talk about those. We've got the schedules. So I've created two schedules for this, a generic model schedule and a rough framing schedule. And I like that generic model one better. So I'm going to open this up and I'm going to change it. I've changed the fields here to use family and type instead of just the type. I'll take the type out like that. And I want to move, no, I don't want family. I want family and type. Family and type. And I'll move it up so it's the first one and go with that. So now I've got lumber, 2x8 lumber, lots of different lumber elements there. So, so I've got these schedules. I would have, if I had sheets in my model, they would appear here. But you see also there's families in the model. And all of the families that I've created are here. And I want to delete the ones that are, you know, the tests that don't have the right names and all. I don't want that header one. It was maybe didn't work perfectly, or I just did it over again. I'll get rid of that lumber. It's going to get rid of a lot of my lumber. So maybe don't do that. That lumber was not used. That lumber was not used. And I can see whether they're used. So there's a lumber test here. I don't think that was, there's one, 4 instances. So we'll keep it. And muntins and plywoods. Now, there are reasons for deleting these things. One is, an important one is that they make your file smaller. So each of these things takes up space in your file, and you just want to make it smaller. Now, another reason is just that it removes the clutter, so it's easier to find what you want to use. You can actually draw these things by finding them in here and dragging that out to your model. And I can place a new one. And I can click on this and I can select all of them in the project. So if I wanted to replace them with a different one, so a good example might be to pick this lumber here. I wonder if I can select all the lumber 10s. No, I have to do them each one at a time. Select all these instances in the project. And I could replace them with my new lumber. Here we go. And then I could probably delete that type so it's no longer used. So, so this is just another way to manage my model. So replacing old families that have been improved, or let's say we have a chair design that we've placed all over our building and we decide to go with a different chair design, we could replace all of those chairs with the new design using this kind of interface. So, so what I'm trying to get you to understand is that the BIM is not just a drawing. It's not just the graphics. It's not just a pretty picture of a building. It is a database of the building that has a list of all of the elements in the building and precise definitions of every element. and ability to manipulate those, to do search and replacement of different elements, of counting them, of estimating or not estimating, getting the actual quantities of everything. And this is transformative in how we think about architecture and do architecture. This is why the firms use BIM. In school, we're focused on the pretty picture. That's great. I don't have a problem with spending time on the pretty picture. It's very important. But having all the quantities, having the physical, digital, the physical model, the model of the physics of the building, the model of the, having the digital twin gives us tremendous power, authority, and an ability to do better architecture.